This episode of the Pumps and Systems podcast is brought to you by SEPCO, fluid sealing solutions for every application.
You just incorporate this iron powder, fine iron powder, into the material, and so it makes it metal. So it's a small percentage of metal in the product that makes it metal detectable. So in that instance, in the event that the seal would shear off, a piece of the seal comes off, or the seal fails and a portion of the seal goes into the product stream, a metal detector in the line can alert somebody.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today we're welcoming back Cody Kaufmann, business development manager at SEPCO, who's going to tell us about metal-detectable polymers, their history, how they're being used in the food and beverage industry today, and what might be in store for that technology in the future. So without any further ado, let's get into the episode. So thank you for joining us yet again on the Pumps and Systems podcast. So we're glad to have you back. And how are you doing today?
Man, it's wonderful. I love spring. I don't know about you, man, but this time of year, the weather's great. Flowers blooming. It's a perfect time of year.
I agree. Yeah, definitely my favorite. Though we're getting some up and down temps here, so not the full benefit of spring just yet.
Yeah. You're in the Northeast, right? If I remember right. Yeah.
I'm in the Midwest. I'm in Chicago,
Oh,
so
that's right. That's right. You're Chicago. That's right. Yeah. So yeah, it's still cold there, but it's coming, man. The
yeah,
warm weather is coming. The birds are chirping. It's really a good day to talk about plastics and those kinds of things, I think.
it's always a good day to talk about plastics. But yes, especially today.
Sure.
So yes, we are going to talk about plastics and about metal detectable polymers in particular. But before
Yes.
we do that, for those who have not had the chance to check out your previous appearance on the podcast, would you mind?
Shame on them.
Yeah, shame on them, first of all. But second of all,
Yeah.
would you mind introducing yourself and telling us who you are, what you do, all that good stuff?
Sure. Yeah, absolutely. Well, I'm Cody Kaufmann. I don't think you actually even said my name yet, but that's who I
Sorry, this is Cody Kaufmann.
am. You're supposed to introduce me. No, I'm just messing.
I'm sorry, I failed terribly.
No, it's okay. It's okay, Tom. It's okay. I'm Cody Kaufmann, business development manager with SEPCO. Last time I was on, I was just the measly plastics product specialist. But
Oh,
so I am a business development manager, really to overseeing new business, right? We're trying to develop new business. So yeah, I mean, for your listeners, I mean, who don't know SEPCO, we're a fluid sealing company, mechanical seals, air seals, bearing isolators, anything and everything surrounding fluid sealing products, including 100% Gore, GFO packing. We are the largest brader. SEPCO, for those who don't know, SEPCO is the largest brader of mechanical packing in the country, largest consumer of Gore products as well. So so that's a little bit of SEPCO, but maybe that's not why we're here to talk.
no,
You
it's
can
good
cut
to have
that.
the background. No. It's good to have the background. Okay, so then let's get into our topic for today, which is
Yep.
metal detectable
Yeah.
polymers materials. So let's start with the absolute basics. So what are metal detectable materials? What is their history, et cetera, et cetera?
Yeah. So last time, if I remember right, last time, Tom, we were talking, I gave a little history lesson on it was biodegradable plastics is what we were talking about. So I'm going to give you a little history lesson as well, sir.
Excellent.
So the beginning of metal detectable materials, specifically metal detectable polymers, starts with food safety. But even before that, it kind of began with a product that's totally unrelated to fluid sealing products, and that is metal detection systems or detectors themselves. Um, I think this is a true story, Tom. I think it is, but you're just gonna have to trust the
We need to
internet on
fact
this one.
check it before we
Yeah,
can
you can,
podcast.
I'm sure your astute listeners would be happy to fact check this this story. But in 1881, right, President Garfield, he was attempted assassination. He was shot, and the bullet got stuck inside of him. And they didn't know where the bullet was. They couldn't find it, and they had no way of finding it. So they called on Alexander Graham Bell. Of course, we know Alexander Graham Bell from his work with the telephone. They called him in to assist, and he devised the first metal detector. And he tested it on Civil War veterans, and he was able to detect these bullets lodged inside of them. But when he took this thing to President Garfield, he wasn't able to find the bullet, and they could not figure out why. Ultimately, they realized that he was laying on a bed that had metal springs on it, and this was interfering with the metal detector's signals. Ultimately, Bell, his invention didn't save Garfield, right? We do know that Garfield unfortunately succumbed to that injury. But that was the first metal detector, right? And that paved the way for metal detection technology. So, like, kind of with all technology, progress and development with that original metal detector was very slow. And I think 50 plus years, we didn't do anything with the metal detector. It kind of, yeah, it just inched along. In the world wars, they used them for detecting landmines and stuff. But as that technology grew into the 21st century, 20th and 21st century, right, metal detector technology grew. By the early 2000s, metal detectors were able to, they were capable and sophisticated enough to detect very small particles, and quickly and accurately. And more importantly, they were able to overcome that issue with the original metal detector, which was the interference issue, because that was the main thing, especially as we look at metal detection within a gasket, and the specific applications that we're going to talk about. That interference was the main problem. So as the metal detector became more sophisticated, that interference issue got better, and the ability to detect very small metal particles became possible, right? So then around that kind of same time, technology in food production was also increasing, right? We're able to automate food production. This was lowering costs. This was increasing food supply. It was a good thing overall for food production, but this issue of contamination, right? When you're automating food production, and you don't have hands on every single thing, right? Or eyes, I guess, on every single thing, the opportunity for contamination um, increases. And food safety was a big deal, and it should be a big deal, right? So in the end, there was kind of this marriage between the increase in metal detection technology, the increase in food production, and the need to prevent contamination, but more importantly, detect contamination when it happened. So that's the history of metal detection, which you didn't ask about, but there you go. And that's the history of metal detectable. How and why we came up with, not we, because I didn't come up with it. How and why
You weren't
somebody,
there?
I
Oh,
wasn't there. No, I wasn't there in 1881, and I wasn't there when it was invented.
wow.
But that's kind of the history. So I think that answered your question.
Yeah, yeah, absolutely. So, yeah, and it's no, it's really good to have that history and kind of understand the context surrounding
Yeah.
this technology. So, if you didn't invent it, let's talk about who did invent.
Who did? I wish that I did invent it, because if I did invent it, I probably wouldn't be here. Right? I don't know, maybe I would. So
You probably
I'm glad
wouldn't
I
be on the
didn't though.
podcast, so I guess it's good for us that you didn't invent it.
Tom, I'm very glad I did not invent them. Yeah. So, big area in contamination was seals and gaskets, right? I mean, in a food production process, if you're talking about where contamination can enter, it's most always the gasket, because the gasket is what's touching the product. And then if a gasket fails or the seal fails, the contamination enters into the product stream there. So the original patent, like who invented it, right? The original patent was for metal detectable gaskets was given to Robert DuPont, not DuPont from DuPont, like Teflon DuPont. If people know that name, it's different guy, same last name. And yeah, is the patent is essentially what they are is it's a fine iron powder incorporated into the polymer matrix. So be it PTFE, Teflon, or any other polymer or an elastomer, right? You just incorporate this iron powder, fine iron powder into the material, and yeah, so it makes it metal. So it's a small percentage of metal in the product that makes it um, metal detectable. So in that instance, in the event that the seal would shear off, a piece of the seal comes off, or the seal fails and a portion of the seal goes into the product stream, a metal detector in the line can alert somebody that there's a problem there. And with most metal detectable polymers, they are colored in a particular way. I didn't intentionally wear a blue shirt today, but blue is the color of most metal detectable materials as the indicator that this is a metal detectable product. And because there's really no foods that are blue. So if a metal detector does go off that, hey, there's a seal failure, there's a piece of a seal, there's some contamination in the product, it's blue, so it's very easy to find and kind of quarantine that particular batch or that, whatever,
Yeah,
that
you just
section
have
of.
to be extra careful if you're working in the blueberry factory, maybe.
And the blueberry factory, you want to be a little careful with that. Maybe we'll do a different color, metal there.
Yeah, but everywhere else
Yeah.
you're okay.
Everywhere else, you're okay. This is true. So that eliminates obviously having products that are metal detectable. It doesn't completely eliminate seal contamination, right? Because it's still a seal, but it prevents you from a seal contaminating the product and you not knowing about it, essentially, right? You can correct the problem. Whereas if the seal is not metal detectable, how are you really going to know, especially in an automated system? Yeah, somebody's gonna consume that, or it's gonna stay in the line, and of course contamination, especially in kind of pharmaceutical applications, and we'll talk about that maybe if we talk about applications a little bit. The introduction of a contamination into a product is not necessarily, it's not the product itself that's the problem, because PTFE, there's a lot of talk about microplastics, but generally plastics are inert. It's like if you consume a little bit of a particle of plastic, it's not going to necessarily damage you, but it's the bacteria and things that can grow as a result of a contamination in the line. So that's ultimately what we're trying to prevent is over time, any contamination in a food product line is not good. Right? We're trying to keep it sanitary. That's probably the best word. Free from bacteria.
And now for a quick word from our sponsors. This episode of the Pumps and Systems podcast is brought to you by SEPCO. SEPCO has been a leading provider of quality products and exceptional service for over 40 years, but we're more than just a provider, we're your partner. Our products range from mechanical seals to compression packing, graphite items, and gasketing materials. Additionally, we offer specialized items like die-formed packing rings, molded PTFE parts, thermal management solutions, and fiberglass products. Find your sealing solution today at sepco.com. So you mentioned like the food industry, pharmaceutical industry. So that is my next question. So where do we use this kind of technology? What sort of industries?
Tom, we're on the same page here, man. I mean, we're just like, man. Um, really, honestly, it's kind of silly, but to say this, but everywhere where there are fluids that need to be sealed involved in food production or food packaging, we find metal detectable products now, like more specifically dairies, right? I mean, that's a big, there's a lot of dairies in the US, cheese manufacturers, right? People who are processing milk products, a big user of metal detectable products, protein production companies, and I say protein like chicken, beef, beef, pork producers, processing plants, so like Tyson and others. Really pretty much any liquid that is canned or bottled. So all soft drinks, all that kind of stuff. And even pharmaceutical, some pharmaceutical, that's a hard word to say. Pharmaceutical applications also use metal detectable. And when I say some, a lot of the pharmaceutical applications have much more strict and stringent quality control measures than just a slap a metal detectable gasket and we'll check it if something happens. But there are some that use metal detectable gaskets as well. So it's really everywhere now. I mean, since the technology, I think the original patent was early 2000s, and since then, since I've been in the industry 20-ish years, it went from not seeing metal detectable gaskets at all to I think almost everybody has some metal detectable version now. And I say everybody who makes gaskets has some metal detectable option because um, it is the technology that people are using now, and because it works.
So then let's shift to talking about some of the strengths and weaknesses of
Yeah.
metal detectable polymers. So we've heard some of their strengths, but let's tell me more. Tell me more strengths
I'm
for
going to tell you more, Tom. I'm going to tell you more. The biggest strength of a metal detectable gasket. Hold on for this one. You ready? It's metal
holding.
detectable. It's metal detectable. That's the that's the biggest strength.
Wow.
Yeah, I know it's shocking,
You
isn't it?
heard it here first, folks.
There it is. Metal detectable gaskets are metal detectable, but there's more to that. It does so without sacrificing too much on performance, right? So a strength is that it's metal detectable and is metal detectable without negatively affecting the performance. Because if you are able to make a metal detectable gasket that was just a crappy gasket, then uh, what's the point of that? So it is still a good seal, right? Obviously. But anytime you're adding a foreign substance to the polymer matrix, you're compromising something, right? Because a virgin Teflon that's doesn't have any fillers in it is going to perform better than a material that you're adding certain fillers to it because you're creating voids, you're increasing porosity and permeability. So you are subjecting it to some negative effects. So what is a potential weakness? Well, certain physical and mechanical properties are lessened, right? So things like tensile strength and elongation are lower. As again, porosity is higher, permeability is higher. The potential for that to degrade over time, that seal to degrade over time, does go up a little bit. So yeah, there are some negative effects of it, and you're also adding metal to a product, right? It's just one more consumable product that you're adding to a material, and not that we're running short on iron, right? I think we're probably okay. Like I don't know, but I think we're probably okay on iron. But it's just one more thing, right? It's more labor, it's more materials, it's more cost, it's more scrap rates, it's all of those things, right? It's just something else added to it, which maybe that means a bigger economy and more products. I don't know. I'm not an economist either, but it's just one more piece to the puzzle. So I think that's a weakness, right? But maybe I said this already, but an additional strength is that any material can be made metal detectable because it is just fine iron powder that's added to the material in anything. So elastomers like Buna, EPDM, Viton, silicones, polyurethanes, any elastomer or thermoplastics, right? Like PTFE and others, they can all be made metal detectable, meaning that there's a whole range now of materials that cover a whole range of price ranges and application ranges to seal pretty much anything with a metal detectable product. So if you need an elastomer for cost prohibitive means, then there can be metal detectable Bunas, and EPDMs, which are relatively cheap products. If you have maybe some more we're talking food grade, so I'm not going to say aggressive chemicals because I hope there's not aggressive chemicals in food products, but there can be products that need a higher or possibly a larger temperature range. So materials like PTFE, which have a more broader chemical resistance and certainly a broader temperature range. Yeah, you can metal detectable those materials as well. And again, it's because of that we've seen this massive rise in metal detectable products over the past 10 years to 20 years, I guess, because you can make so many products metal detectable now that there's no reason not to, really. If you have a static seal and you're using stuff in food production or you're sealing food production applications, I don't see any reason not to. Because like I said, you don't there's the negation or the negative effect of the metal detectable fillers don't degrade the performance enough that it's negligible, really. So yeah, there's no reason not to use it, in
Okay.
my opinion, sir.
In your opinion, okay. So then, have there been any new developments in metal detectable polymers or materials that you can tell us about?
Yes. Some tangible ones that have actually happened, and then some theoretical ones that just come from both my brain and the kind of the rumblings that I hear. So as detection um, metal detection technology increases, the gasket technology, of course, is going to follow suit, lagging a little bit behind, but it always will. So there's fillers now that we can put in the same materials that make the gasket visible on X-ray machines. So like TSA style X-ray scanners. Um, so as opposed to metal detection, this is X-rayable material. So and they use those X-ray in a lot of food production as well. So being able to detect a product, having the X-ray technology, you could detect a gasket above and beyond just metal detection, but you could detect some sort of contamination buried in a product, hidden, or internally in a product that maybe the detector wouldn't set it off, but an X-ray would see it, right? Kind of hidden underneath. So that technology is available as well, and there are metal detectable products, there are X-rayable products, and there are products that are both X-rayable and metal detectable, kind of in one. And then thinking kind of further into the future, when metal detectables can pick up on these very minor changes and intensities of metals, and even distinguishing like depths of metals and kinds of metals, like all of that technology is increasing, being able to differentiate between specific gaskets, like a metal detector would know not just that a gasket is present in the product, but it could fine tune or have, like, each gasket could have its own metal detectable signature, so that when the detector goes off, it knows not just that there is a gasket present, but where that gasket came from, possibly what line it came from. So you can actually backtrace a little bit better, because right now when they detect a gasket in the line, they don't know exactly where it came from. So you got to do a lot of research to figure out where that failure happened or that contamination happened. So as the detectors are kind of fine-tuned a little bit more, I think they'll be able to add certain fillers or certain materials into the product that the detector will be able to tell the user exactly where that gasket came from. There won't be any guessing. It'll tell you that this came from this location or this line or this area of the production facility or whatever. So yeah, that's pretty cool. I think that's not too far-fetched theoretical. I think that will happen. And then as metal detectors get even more and more capable, we'll be able to reduce the amount of fillers in the products so that they're still metal detectable with less of the filler in there, which will increase performance even more, right? So you'll see these products continuing to get better and better I mean, they're already great, but I think as the tech grows, the products they'll just get better. They'll last longer. They'll seal better. The performance overall will be increased. So yeah, I think the tech is cool. Like it's interesting. It's innovative. It's saved a lot of time for a lot of people. It saved a lot of money for a lot of people. And I do think it probably has saved some lives as well. And I think that's what's special about the fluid sealing industry as a whole. Certainly what I do. We're not just like keeping stuff from leaking, Tom. We're trying to make people's lives better, healthier. We're trying to do a little good along the way. That's what we're doing. So, really I'm not just a sealing guy.
A
You're joking,
ceiling
Tom.
superhero.
There it is. That's what I was looking for. It's not true.
No, but it is very important work, and as you said, I'm sure it's saved people from illness and possibly worse.
Yeah, all jokes aside, it is true. And there's a lot of smart people doing a lot of good work on this stuff, and I just get to talk about it, and it's fun. So so there we go.
That works out well for us.
Yeah, that's it.
Okay, well, before we wrap things up, is there anything else you want to tell us about
Oh,
metal detectable polymers or anything else that you have to share with us?
you did this to me last time too, and you kind of threw me these curveball questions
Uh,
at the end, and I'm like,
is it a curveball when I do it every time though?
this is true though, Tom. This is true. I should I
But
should be
yeah,
more I should be more
but
prepared.
it doesn't have to be this is not like a case of like tell me more. It's more like,
Yeah.
is there anything else you want to share? And if not, that's fine.
Yeah. No, I'm with you. No, yeah. I mean, I think again, I think the metal detectable technology that we've talked about in polymer materials and elastomers demonstrates a broader point, which is the technology of sealing solutions is continuing to grow, right? So, metal detectable materials is one of many innovations that have happened and many innovations that are continuing to happen in the fluid sealing um, arena, and they're going to continue. People are smart, man. They're doing cool stuff all the time. So yeah, I hope innovation continues to happen as I know it will, and so it gives me something to talk about so that I can keep coming back on the show and talking about interesting stuff with you, Tom. And I hope there's plenty more conversations and plenty more new things that we can see.
Yeah,
Yeah.
I hope so. All right. Well, then thank you so much for joining us today and sharing all of your expertise as a sealing superhero and not the inventor of detectable polymers, but someone who enjoys talking about them.
There it is. There it is. And you did call me a superhero, so I'm gonna take
Yeah,
it.
yeah.
Thank you, Tom.
Huge thanks to Cody Kaufmann for taking the time to talk with us today about metal detectable polymers. And an even bigger thanks to SEPCO for sponsoring this episode. If you're listening to the podcast and would like the chance to watch it, head over to our YouTube channel for the full video version. That's going to do it for today. Thank you so much for listening or watching, and we will see you next time.